welcome Roland Busch to the stage.
I want you to think back to the time before electricity. The world moved at the pace of people, horses, and bridged our distances. Steam powered our engines, and ideas moved only as fast as a letter or a human voice. Then electricity arrived, a general-purpose technology that turned night into day. It amplified human capabilities and powered progress that once felt out of reach. At Siemens, we helped build that world. Electric grids, telecommunication, the trains that move people and goods, machines that accelerated production. 1.5 centuries later, another general-purpose technology has arrived. And this time, it is not about energy, it is about intelligence. It is about artificial intelligence. And artificial intelligence will be as transformative for this century as electricity was for the last one. It is revolutionizing how we design, build, and operate infrastructure, making entire systems, grid, cities, economies more adaptive and more efficient. Siemens helped build the world in the light of electricity, and now we do it again in the age of intelligence. We are powering the industrial AI revolution. And it's moving faster than any transformation before. For steam, it took 60 years. Electricity, 30, computers, 15, and AI, 7. And by the way, half of the time is already gone. When AI enters a physical system, it stops being a feature. It becomes a force with direct, real-world impact. But AI that runs a production line, manages a power grid, or steers logistics network has to be reliable in the real world, reliable and safe. So hallucination is not acceptable in industrial AI. What's the solution? It is not about going more slowly as we develop AI for the real world. It is more about having embedded AI technology from the beginning, right from the beginning when you first start using it. And that's what sets industrial AI apart from the AI on your phones. In the next 40 minutes, we will show you the tools that are ready today to help you make progress with industrial AI and how you can use them to create value at every step. Design, build, and operate. Well, it starts all with an idea. Ideas becomes designs, and from designs, you start building. But long before you build anything, you want to know, how does it actually work? And how? Siemens software helps you find those answers really very early in the process. Our tools allow you to build digital twins. Digital twins, they are replicas of whatever you want to create. They are physics-based, photorealistic, in 3D, and real-time. So no matter whether it is a machine, a factory, an entire logistics network, you run the twin. You stress test it, you break it, of course you break it virtually, and then you spend not a single euro on really building it, not before you know how the real thing works. And only when it works in the digital world, then you start building it in the real world. Our customers take it one step further. With our digital twin composer, they connect digital twins of machines, of production lines, of entire buildings, and they make them play together. One integrated simulation. Take Kion, a leading logistics company. Their forklifts and automated vehicles keep warehouses moving and supply chains open. With our digital twin composer, the company can now test virtually how different warehouses layout affects throughput before moving a single shelf. Looks fun, looks easy, yes, but all these simulations are hard, indeed, seriously hard. Where it becomes almost impossible is aerodynamics. That means, for example, calculating the airflows around a moving object like a car. Exciting stuff, at least for me, but then I'm a physicist after all. So what you see here is a wind tunnel simulation of a BMW, and normally these calculations take days. Now, with accelerated computing from NVIDIA, we drive them by a factor of 10, 100, or sometimes even 1,000 times faster. That matters in highly competitive industries like automotive. Or take passenger experiences. To avoid uncomfortable vibrations, car makers needed a complete 3D simulation model. Hundreds of thousands of tiny rectangles or triangles on a mesh. Build and simulate just one model took weeks. So testing another one, you start all over again. Now, today we are announcing at VivaTech, now our software simulation, Simcenter SimSolid, eliminates this testing and meshing entirely. Instead, straight from the design, you go in the calculation in your physics, and it takes minutes. Every structural calculation an engineer needs, vibration, thermal, fatigue, 30 times faster. Speed also matters if you plan to disrupt a whole industry as a startup. And that's why today we are announcing at VivaTech our software collections for startups. We give up to 95% of discount for startups for design, engineering, and simulation collection. Faster product design and simulation, much more affordable. Our technology really makes the difference. Take the example of Latitude, a French startup, and they built rocket engines, 3D printed for small satellite launches, and they switched from a patchwork of tools to our software suite. The result, 6 months speed on project delivery, 15% higher engineering efficiency. That's how you turn ideas into design at the speed of AI. The next step is to engineer the production. Let's look at the reality as of today. First, manufacturing engineers create automation code. For this, they work on our TIA portal. It's an engineering tool and software engineering platform where they find all what they need. Automation components, controllers, motors, switches, sensors, thousands of them. In this environment, engineers configure all components. They document what they do, and they test and debug until their code works perfectly. And this takes time, a lot of time. It's a repetitive work on top, but this is about to change. Less than 2 months ago, we launched a new revolutionary AI product for industrial automation. We call it the Eigen Engineering Agent. And it's not an AI chatbot that only comes up with suggestions. It is an industrial AI agent that completes engineering tasks end to end. So it operates inside our TIA portal and it works autonomously. You define the outcome and the engineering agent makes a plan, collects the documents and all the data. It writes executable code for your controllers, compiles the whole thing, and validates it over and over again until the code works and it's compiled without an error, ready to implement. What is the feedback from our customers? 50% higher productivity, 2.5 times faster development, 80% higher quality. And today at VivaTech, we're announcing 2 new capabilities of our Eigen Engineering Agent. It understands now, additionally, parts of automation projects, very important ones. Now, it is grounded in plans from electrical design tools and automatically integrates that information into our TIA portal, ready to use for all the engineers. What used to be days of manual work now takes minutes. Secondly, the Eigen Engineering Agent has learned to build exactly along the common norms of your company. The agent now works with your engineering framework, that's how they call it, hundreds of pages and documents, thousands of rules, and comes up with a correct software structure which is compliant to your frameworks. And that fits perfectly. And again, in minutes. These capabilities move our agent upstream in the workflow. That's what industrial AI looks like. It's not hype, no hallucination, it's real impact. So, we have designed, we have built, and now the crucial moment starts. We bridge into the real world. Production in a real factory where thousands of decisions need to happen in parallel with real-world consequences. Industrial AI finds the hidden potential in your machines and processes. It reads faster than any operator could and learns with every single cycle. So let's take a look at this welding line at an Audi plant. It had been running in the real world for years. What you see here is robot arms welding car bodies with millimeter precision. Then comes the quality check. Multiple cameras capture the process. They do that 2,000 welding spots per minute. And this piece of hardware, it's our industrial PC, is checking 2,000 welding spots a minute. It has a trained AI module in the cloud which runs on the edge. It works on a NVIDIA GPA. It's the brain which we're bringing from the cloud to the shop floor, inspecting, evaluating, and reporting. And now imagine this intelligence across an entire factory. In Erlangen in Germany, we produce the components that make electric motors run efficiently. And we are turning this factory into the world's first fully AI-driven production site. So far, 100 AI algorithms work on the shop floor. Digital twins, intelligent automation. What's the impact? 40% faster time to market, 42% lower energy consumption, 69% productivity increase. Imagine these results in your production sites. And we don't stop here. In Erlangen is our blueprint for the factory of the future. Here, we use physics AI to automate tasks that have simply been out of reach by reasonable cost. For example, looks simple, placing a plastic bag of screws into a package. But these bags, they are flexible, difficult to grip, unpredictable in shape, so no conventional automation could handle this at a reasonable cost and with the highest quality requirements on the shop floor. Physics, AI can. We taught the system what to do. If something isn't placed correctly, it detects and corrects itself. Every factory has hundreds of tasks like this. Tasks that were never worth automating until now. 2 lightweight robotics arms, minimal programming, and maximum flexibility. And the colleagues have more time for the work they really need, their expertise. So the tools are here. So you might wonder, why do many companies get stuck in pilot after pilot rather than scaling? And let's learn from companies that are doing that successfully. And for this, I would like to invite my fellow board member, Cedrik Neike.
Thank you so much, Roland. Bonjour, Paris. I will do a quick experiment to wake you up. I don't know if it's going to work, but it would be great if you could help me. So it's audience interaction. I'm going to ask you 3 questions. First question, please raise your hand if you use AI on a daily basis. Just raise your hand. It's very simple. Thank you. Very good. Second question. Are you not only using AI, but are you driving within your organization an AI project? Please raise your hand. All right, and now comes the more difficult one. Please raise your hand if you are driving a project which is actually super successful and generating return of investment. Please raise your hand. These few people, can you stand up? Stand up, please. The people, stand up, yes. You have to commit. All right, so there's fewer people. Look at them, they're the heroes. Give them a huge round of applause because there's very little of them. Get their contact. You can sit down, it's all over for you guys, so sit down. But at the end of the day, what I was trying to demonstrate, we all talk about AI, we all use AI, we all try to push it forward, but we fail, and we fail particularly in a lot of industrial environments. And the question is why is that the case? So, there is something which I call the 3 traps of adoption of AI in an industrial environment. I call them the industrial AI syndromes. So, 3 ones. Let me start with the first one. The first one, I call it the spray and pray syndrome. So you try to shoot AI at everything. You define somebody as called, which is Chief AI Officer, and he does a lot of pilots. The joke, and the Germans are not very good at jokes, but the jokes in our German company, we have more pilots than Lufthansa, right? On a plus de pilotes que Air France would be the French sort of aspect of it. The problem is you get lost in pilot land. So you do, instead of having one plant you really define, you're doing as much as you can. First mistake. The second mistake is what I call the foundation syndrome, right? Once you have these islands, and it was the same when you went to Industry 4.0, you had digital islands. They were all not connected. You had little pilots, little trials. None of them were connected in some ways. I call it the foundation syndrome. So the hard thing you have to do is you need to build the foundation within your company to be able to do it. You need to do it in your CRM system, in your PLM system, in your ERP system. You cannot. We talk so much about this huge treasure which sits in European companies. If this structure is not structured, you cannot access it. So the second thing you need to do is you need to build a foundation. And we're brutal about it at Siemens. We basically call it the fabrics. We are forcing everybody to have the same structure, capability, so we can build our models on it. So what's the third one that will appeal to a lot of the French people here? I call it the lonesome cowboy syndrome. What is it? It's a bit like Lucky Luke. You're really sort of doing it on your own. You don't need any help. You just push the AI projects on your own. But the reality is you are often falling into the trap of not being able to scale it. So the 3 main elements which we have is how do you go about it? And I'm going to bring somebody to help me discuss it, and I'm going to bring you two very clear examples. But the three traps are very, very simple. The first one is you basically are trying to shoot at everything. Second one, you don't have a foundation, and the third one, you do it on your own. So in order to do this, I want you to help me to give a huge round of applause for Aiman, the CEO of Capgemini Group, which will help me give you an overview on how we do this. Thank you, Aiman.
Hello.
Look, good to have you here. And Aiman, I shared my three principles, the spray and pray, the missing foundation, the why is it so hard to bring AI into the industry as a lonesome cowboy. So give me a quick overview, quick intro from your side.
Yes, I mean, so basically we run Capgemini and great partnership with Siemens for many years. You know Cedrik well, he speaks French.
I pretend to.
No, he's very good. So really, when we look at deploying industrial AI, it's really a lot more complex and a lot more ambitious than using generative AI tool for productivity. I mean, we're talking about a different word. So we're talking about rewiring completely organizations and designing completely new business models with two key types, two key elements. One, we talk about new agentic product and services. And of course, here, we're leveraging accelerated R&D cycle, AI-enhanced software, and of course, physical products to be able to do that. And the second thing is the new agentic business processes. So we are redesigning how works happen. We are blending employees, humans, with AI agents to get the work done. But for that, we all know that we need strong foundations. The first one is on the technology side and the solid data fundamentals. If you don't have that, it's very difficult to progress. Then you're deploying AI agents. AI agents are human digital workers. And for that, you need very strong governance, you need very good control mechanisms, and you need a very strong operating model. If not, it's like deploying hundreds of employees across the company out of control doing what they want. And you'd have chaos in your company if you don't have the proper governance basically to be able to manage these agents. You know, we talk about the control plane, about how we're going to manage all these AI agents. And beyond chaos, you'll also have a big consumption of token. So the governance and how we manage that is very important. And finally, you have the human side. Having AI agents and human working side by side is not the simplest thing. Because if the humans doesn't trust the AI agent, it's not going to work. So basically, you are spending money for nothing. So that's really what we have to do as basis to be able to
Absolutely, do it. And you talk about trust, humans and AI agents trusting each other. We trust each other, and we're going to bring about two companies. Why are we actually working together? Can you give you an overview of why we're such a good fit also?
I think because it's a great complementarity. You know, from a Siemens side, you bring all the technology and the tools, right? You meet domain know-how in many industries, you know, from process to hybrid to discrete industries, both in automation and software, which is very important. On our side, we bring all the strategy and transformation capabilities, the end-to-end deployment really in complex environments, you know, and a lot of capability in terms of AI ecosystem management and in terms of course, new business model. And we deploy that across industries, you know, together from aerospace to consumer products to automotive to water. And of course, we're building on the trust we have between each other and the trust we have with our clients.
So one of those clients is GravitHy. Can you give us an overview of what you do with them?
So we are in Paris, right? You have the Tour Eiffel, 7,300 tons of steel. So, of course, steel is a key component in our world today, bridges, cars, electric cars, many other things. Small issue with steel, 8% of CO2 emission is coming from steel.
In the world, right?
In the world, yes. So GravitHy came up with the idea of building a green steel plant in Marseille. Okay, 2.2 billion euro investment. Small thing. We replace coal by hydrogen, right? There's HI for the hydrogen at the end of the name. And the reality, what we're aiming for is 2 million tons of steel produced every year. which means the equivalent of almost 1 Tour Eiffel every day, which is impressive. The only issue with that, there's no pilot plant. So you get to go only at 1-2 billion investment. If you miss it, too bad, you cannot go back. Hence, we have worked together to build really a digital twin of the factory and of all the operating model to be able to simulate all the operation of the factory to make sure that we basically get it right, but also build as well an operation, the agentic AI layer on top of that. So from an operation perspective, we are able to have a learning environment, pretty much a learning factory. It's really the control brain of the factory that learns on how to optimize the hydrogen consumption on a real time, do predictive maintenance, etc. So not only we have a great factory optimized and built, but also it's what we can call now a learning factory that can basically learn and improve every day.
And that's the advantage, as we've talked about digital twin for the last 20 years. So if you build a digital twin, but with AI, you supercharge it to come up with the right solution very quickly, it makes a huge difference, right? But let's stay in France and let's look at another player like Sanofi.
So Sanofi, GravitHy is about reinventing an industry. And of course, every industry has its own problem and its own challenges. So in pharma, the mission sounds simple. You need to find the best and safest and most effective medicine for patients. But of course, getting there is quite complex. And basically, the challenge, of course, in pharma is basically you have plenty of different factories, plenty of different sites across the world, and it's a very regulated industry. And a lot of what you're trying to do is basically how you're going to scale. And to be able to scale, it's a very challenging point. Why? Because a lot of this information in a regulated environment, people manage a lot of that data in a manual way. And of course, it is much more challenging to be able to replicate from one environment to another. The issue is going to be around scalability. How do you scale? Okay? And of course, at this level, where you have 100 production lines across 50 manufacturing sites, scaling is not simple. So Sanofi has what's called smart operations, okay? And that's what we have developed with them. So it's a manufacturing execution system. And what you do here is really the cornerstone and the foundation of how you make it happen. It shows what needs to happen. It records what actually happens. It guides everybody step by step. It holds electronic batch records, not manual paper. Instead of searching through documents, of course, the team can see right there in the right place the information that it needs. And Sanofi, we are working with Sanofi, with Siemens, to be able to roll that across, of course, all the manufacturing sites across the world.
So why is that so important? Because everybody here knows Moore's law, right? Moore's law basically means you have an exponential sort of advantage in terms of cost structure through the development, which we will share with you later on the microchips. In pharma, we have something called EROM's law. So if you spell Moore's law the other way around, you basically create something which is there because every 9 months, the cost of developing a new drug doubles. So it becomes more and more expensive building drugs. So we need to be able to use AI. We need to be able to use digital twins. And we need to link because it takes 15 years to launch a new drug, plus 3 years to put it into production. And building this together actually makes a huge, huge difference. So the impact is very concrete, right? We have 70% advantage in batch reductions, 80% less deviations. So it basically means that AI brings something to the bottom line, which was my question I had for all of you. So we talked about 2 industries. We talked about 2 companies. And what did they do right? They did not have 1,000 AI projects, right? They built the foundation on how to build a digital twin and simulate it, or the foundation on how to run their factories and their R&D. And they went with partners. They went with us. They could also go with other partners. The takeaway for us is that it will become easier if you focus, if you build the foundation, and if you partner as much as possible. So Aiman, so much thank you for joining us today, giving the overview and absolutely see. And I talked about EROM's law, which basically meant that we need to bring AI into the pharma world. I'm going to go back to Moore's law and ask actually Roland to go back on stage with a very special partner to talk to you more about this. Thank you so much.
Well, two industries, two companies, one winning formula. They did not go for 100 pilot projects. They are building the foundation, and they went with partners. That's the takeaway of today, that the rest becomes much, much easier. So, Aiman, thank you very much for joining us, and we will continue the work which we did in the past. Every AI success story you just heard runs on one thing. It's compute. Compute means chips. And chips need a home, a physical home. It's energy-hungry data centers. And if they're loaded with GPUs, you call them AI factories. Together with NVIDIA, we've developed the blueprint of the next generation of AI factories. They are pushing the limits of conventional design and operation tools. We optimize the energy use and cooling system for the lowest cost token per megawatt. How? Of course, with digital twins of every single subsystem. And then remember, our digital twin composer, we're using it now to simulate the entire AI factory as a complete, very complex system before a single cable is laid. And by the way, once you have built an AI factory, you better keep an eye on it because it's very expensive. A single power fault can destroy millions worth of equipment in milliseconds. How do you do it? Well, back to physics. AI factories run on direct current, DC. Solar panels on the roof of a data center, they generate power, and guess what? It comes with DC. Batteries to store energy there come with DC. Every chip runs on DC. When the entire system speaks the same language, obviously, you do not want to waste power in conversions from AC, alternating current, to direct current. That's why the whole AI factories will run on DC, end to end. But when something goes wrong, direct current is much harder to switch. And here comes our circuit breaker. This is a new device. It interrupts faults in milliseconds, 1,000 times faster than conventional mechanical systems. And think about what you've heard, what you're protecting here. Tens of thousands of high-performance GPUs worth millions. And by the way, these switches in their lifetime, they switch a million times. That's for sure often enough for the lifetime of a whole AI factory. All of this is only possible with the most critical component of all. It's the chips. Making those chips is a very complex engineering challenge, and there's one company in the entire world which is depending on, in this manufacturing processes, on one company, which is ASML. They built machines the size of houses. Those machines, in turn, create the smallest structures humans have ever built. Please welcome on stage Christophe Fouquet, the CEO of ASML. Hi, Christophe.
How are you, my friend?
Good to have you. Good to have you. We're going to sit here. So, I just said, at least the biggest, maybe the most complex machines I know, they are writing the smallest structures. We talk nanometers. You use light which doesn't exist really in natural life with amazing technology. Do you ever think about holy shit, how does this whole thing run?
Well, we have to, because you know, we have hundreds of those machines across the world, and those machines have to basically print those AI chips, you know, every day, every night. and they run almost all the time, 95% of the time. When you think about your car, right, you run your car maybe 1-2% of the time, right? If you had to run it 95% of the time and a lot was depending on it, you'll be a bit more stressed. So I think it's a very important thing indeed, but part of the complexity of the machine is, in fact, to make sure that they can run without too much failures.
And the other point about this running them really with the highest precision and uptime is that, I mean, we don't talk about the price of your machines. Some people are saying they're very expensive. I would say it's value for money. But Moore's law, also in cost, work only if the machines are really working day and night, right?
That's right, that's right, that's right. So the economic has to work. So yes, those machines are expensive. One more reason to keep them running, because when a machine goes down, this is, of course, a major economical issue for our customers.
How many components does a machine have, roughly?
More than 20,000, right? So this is another way to look at the complexity. You talked about the size of a house. People always look at the size. I think the number of parts, components is very important, because a lot of those parts were designed basically for those machines themselves, right? Because the technology is unique. A lot of the technology composing the machine is unique, so all those parts have to be created basically almost specifically for this tool.
So here comes the beauty, because your engineers are working with Siemens software.
Yep.
You design your machines with our software. We have Teamcenter with our data backbone, which holds all the information of these 20,000 pieces in the design phase. And that's where we're working together.
Yep.
And then you came back and said, Roland, what I need to know at every point in time, design phase, manufacturing phase, commissioning phase, which piece, which part, which component sits in my machine, right?
Correct. And 20,000 parts is a lot, and you're right, we need to have the design information, we need to manage the entire bill of material, to design, to manufacture, to service, and we need to trust the information, because, you know, if not, we're lost, basically. And the other important things, we want to innovate in ASML, so we want our engineers to really spend their time, basically, on innovation. Therefore, as less time as possible managing those kind of things. Therefore, the quality of the products, I think Siemens provide, is key. And that's why we have this great dialogue for many, many years.
And here I'm sitting next to a very demanding customer too. So they always want to have more capabilities in our software to run it faster, more efficient, and we love that. What's next? I mean, will these machines getting more complex in the next couple of years?
I think that, you know, they did become more complex over time. I think we still have ideas for future machines, of course, because the requirements are changing. Innovation require, you know, when you come to this kind of limit, you talked about nanometer, right? Everything you do is complex. And you touch very, very difficult part of physics. We talk about plasma, we talk about things that are very, very difficult to understand. And this is where AI also become important for also the design of our machines, because it gives us a chance, using a lot of data we have collected, to basically try to maybe do things a bit differently, things that maybe a human alone cannot do. So we see AI in this sense as also a next frontier for innovation. So
right.
Most probably AI will help us to take one of the next steps when it comes to technology.
And that's what we're working on. I talked before that we are using now our simulation tools. We rewrite the code to run on GPUs, which makes them 100,000 times faster. Right. But this is only one thing. It still has the same purpose of having simulation which validates your design. Now we want to have our software trained on your former designs, right. So to create new ones, new ideas, right. Which eventually comes up with new ideas, and your engineering don't. But still, we should put it in a box. We call it, therefore, physics-based simulation, because the physics tells you the limits, so that wherever you build it, it's not a hallucination you build. It will finally work. But that's something which needs a lot of training on design data, because that's what models cannot do yet. They don't have domain know-how, they don't have the contextualization, and they have to be trained on the data. And that's the next
Yeah,
challenge,
so there I think we fully agree. I think I said it before, data is key in the value of AI. But maybe one question for you, because I think we already mentioned the word AI a few times. And well, we know each other pretty well, and we know that developing this entire AI stack, you mentioned that a few times in your speech, is difficult. We are two important companies in Europe, Siemens, ASML. We have a few more friends, right, which we brought together with the tech creators.
Yes.
So what do you think we should do to help Europe to really become competitive?
Yeah, here, partner in crimes. For those who don't know that, tech creators is a bunch of companies, amongst them ASML and Siemens, we are really promoting at European level to, let's say, to regulate, but in a meaningful way. We are not against regulation, but we want to have meaningful regulations. I would say we have a success, because on the AI Act, the regulation is not regulating machines the same way as they regulate consumer data and the like. Right. So that's all consumer AI. First, the second would be, now we have, next step for us is, I guess, the Data Act. Right. Because again, I mean, you should treat personal data differently than machine data. And so we are, I think, I mean, the short answer to your question would be, we hope that we can have a Europe which is not over-regulating, but is also giving us an environment which gives us tailwind in a world where technology is changing everything so fast. So we should not go there to prevent slowing us down, but we should try politics to help us a little bit.
And I think we agree, I mean, for our companies, I think we are fully aware that if we don't use AI, if we don't embrace AI, we'll fall behind.
Exactly.
I guess it's the same at the scale of a country or a continent.
Exactly. And the other one is speed. I mean, I believe we are, the gap is opening as we speak. We're over-regulating here. If you look at the most innovative markets, which is the United States and China, you see that there's a gap going up. And if you're not accelerating faster, you have a problem. This is where I said, recently we have to get into this crisis mode. Crisis means you understand you have a problem, yes. Number two is you focus what to do and what not. And number three is speed, because you have to solve it. That's we are up to right together.
So you use AI a lot, and you use regulation a lot. So I guess most probably that's a good message for the company.
Anything on top?
No.
And we have to join forces. Well, thank you very much. It's amazing. Thanks for the partnership. Thanks for being a demanding customer. We like that. And
we'll continue to be a demanding customer.
Thank you. Thanks. Christophe Fouquet, CEO of ASML. Think about where we started today. We flip a switch and the room lights up. None of us in this room thinks much about it, right? Electricity has become a fact of life. But it took a lot of effort to get there, to build the system that we take for granted today. Soon, industrial AI will be a fact of life too. Factories will adapt themselves. Machines will ask energy, will ask for maintenance, and before they break even, an energy will flow cleanly. Industrial AI will be as transformative for this century as electricity was for the last one. It's revolutionizing how we design, how we build, how we manufacture and operate infrastructure, and how we create value in every industry you can think of. If you find this interesting, well, it is still early enough. With good ideas, with hard work, and the right partners, you can build every successful business in industrial AI. Well, with that, I hope that I've been able to demonstrate to you that industrial AI is already there. There's a lot of tools, but still much, much more to do. Thank you very much for your invitation, and keep on going and using AI. Thank you.